Well, greetings, Mr. Kolazar's class. Section 18.2 is going to look at our models of acids and bases. And now a model is going to just be something that's going to explain a concept at the molecular level. So it's not completely correct, but it's going to help us come up kind of some visual ideas of what's happening. And our models we're going to look at are the Arrhenius model, the Bronsted Lowry model, and the Lewis model are going to be the three different ones we look at when comparing acids and bases. Bronsted Lowry is going to be the one we most commonly use. We'll also use some of the Arrhenius model, and we're only going to look at the definition of the Lewis model, so describing acids and bases. Now the Arrhenius model, substances that contains and ionizes to produce H plus ions in water solution. An example of this would be if we were to take hydrochloric HCl, which actually is a gas to begin with, and if we were to put it in water, H2O, is what needs to be dissolved in order to get our hydrochloric acid, HCl would separate into hydrogen positive aqueous ions and negative chloride ions. And so in this case the HCl is going to be an acid because it's going to produce H plus ions. The Arrhenius bases then are going to be substances that contain and then ionize to produce OH, or the hydroxide ions in water solutions. So an example here, sodium hydroxide, solid. If we were to put it in H2O or water, when it's in water, it's going to ionize to produce sodium ions and hydroxide minus ions. And this part here is what is produced, or what has caused the base. In the top example, producing the H plus when dissolved in water, becoming the aqueous solution, cause it to be the acid. So for a couple practice problems, if you are given a substance, you'll need to be able to identify, is it going to be an acid or a base when dissolved in water? So acids, remember, going to have the H plus ion. Bases, remember, OH minus, or hydroxide ion. So calcium hydroxide, when we think about splitting it apart, gives us the hydroxide. Sodium hydroxide, NaOH, when it splits apart, would give us another base. HNO3, when we split apart, gives us that H plus, nitric acid, would be an acid. KOH, if we can see that OH there, when it splits apart, it's going to make a base. H3PO4, we actually have 3 hydrogen ions. Later on we'll see what can happen with each of those. It will split apart, those hydrogen ions, to produce acids. And HC2H3O8, that H will split apart from the rest. It's known as acetic acid or vinegar. So our acids produce the H's, or H plus, bases the OH minus. Now the Bronsted Lowry reaction, or model, is going to look at hydrogen ion donors, versus Bronsted Lowry base is going to be hydrogen ion acceptors. So an example here, HF, or hydrogen fluoride, will donate a hydrogen ion to the water. So in this case, if it donates the H plus, so that we form the fluoride ion and the H3O positive, remember this is the hydronium ion from earlier. The hydronium ion is by definition an acid, versus the Bronsted Lowry base, which is going to be accepting an H plus. So if we have NH3 plus H2O, and NH3 is going to accept a hydrogen ion to become NH4, we also now, from losing the ion over here, we have our hydroxide ion, and the hydroxide ion by definition is our base. So accepting the hydrogen ion, that becomes our Bronsted Lowry base. If it donates a hydrogen ion, that's going to be the Bronsted Lowry acid. And the last one, from our Lewis structures, from linking back to our Lewis dot structures is where this actually comes from. Our Lewis dot structures, all you need to know is the definition. So Lewis acids are going to accept an unshared pair of electrons. So if you have a Lewis dot structure like NH3, we would have a lone pair of electrons around that nitrogen. BF3, no lone pairs around that boron. So an acceptance that accepts an unshared pair of electrons, boron accepting that shared pair, versus Lewis base substitute that donates the unshared pair. So as it donates, for sharing there, would become our Lewis base versus Lewis acid. Just need to know the definition of this one. So examples, our model, Arrhenius produces hydrogen ions or hydroxide ions for the base. Bronsted Lowry donates the hydrogens and accepts the hydrogens for the base. Electron pair is accepted, electron pair is donated. So our models have just changed over time. To begin with, we had hydrochloric acid, H and sodium hydroxide, both of those giving us H plus and OH minuses. Later came the Bronsted Lowry, where NH3 could accept an H plus, and then later on, Lewis structure, aluminum chloride can accept a lone pair of electrons, and so as it accepted that lone pair of electrons, became a base also. So just a couple examples of how models have changed over time.